Hello everyone. Today I'll be showing you why you shouldn't insert multiple footing at a go. Why it is very important for you to insert it one after the other with this simple two one story building. My name is Adasi Unel and I'm your instructor. Now, looking at this, you can see from the plan, this is the plan we have. So we scroll down to our zero. We have numerous plan. We have the ground plan here, which I've already modeled and finished. You can see my slab and my beam. And you can also check on the second floor. This is my second floor. This is my roof beam. So I already analyzed all these members. So we're going to go to the story zero, where we're going to analyze and design our foundation. So on this foundation, you know how we do it. You can simply click on it, then you right click and you locate your insert part base, you click on it, then you specify all data. Now I've already done this. I want my footing depth to be on 350 millimeters. So, and my soil stress, that is the soil bearing capacity, I want it to be this because we've done the soil check and this is the result we got. So I've already implicated it and we selected all the bars. I want it to be 12 by designing my basket in both directions, from the y direction and the x direction from our basket. All data are being input. So the next thing we'll do is to click on what? Click on calculate. So click on calculate right away and it's going to calculate it. So we want the square footing. You can see all design made by 1.4 millimeter by 1.4 millimeter. I want a square footing. I don't want a rectangular footing. So you can do well by seeing the calculation. You can see all calculations being checked, sharing and punch and being checked, and it's being durable. And specification of spacing is being checked by 150 millimeter spacing, and the bar is 12 meters indicated in our instruction page. So in doing this, you just click OK. So and we'll go to OK. And you can see here is the bars. See, can we do another one? Let's just go again and do another one. We'll click on this, we'll right click, you right click, insert part base, you click on it, all the tasks are well, put, you don't need to do them again once you've done it. So you click on calculate and here you can see now there's a difference. The former one was 1.5 and this is a meter, 1000 millimeter. So this is 1 meter. So you click on this, you can choose to, in as much as what you have on your L and what you have in your Y span length are same. So you can still click it and you say okay, and we'll come over here and say okay. So it's going to display. Now you can see the different depths. So now this is what I want to show you. Why you shouldn't click all of them, why you should do them single, just like what I've done. I did this one, I did this. Why you shouldn't highlight and do multiple. So if we highlight this at a go, you can see we've gotten all these 9 columns together. So if we do this is almost 13 columns. So why you shouldn't do this 13 columns together? What you do is, if we do this by highlighting all of this and we click insert part base, what do? You click on this and see it's telling you that create typical footing for the selected column. So if you're doing this, it's trying to tell you that you want to generate a particular footing. What does that mean? It means it's going to take one load. It's going to take the highest load here. It could be this, it could be this. Like the one we've done, you can see in this area we have 1.5 here, and over here we have 1 meter. So if we say we are going to highlight all of them, it's going to take maybe the highest depth like 1.5 and design for all. It's not going to specify one by one, telling you okay, this is 1.5 and this is 1 meter. So in doing this, cost wise, because when you're doing a foundation, it should also cost that cost. You understand? It should also cost that cost. So that should be in your mind. So if you do this, it's just going to take one and design for all. Hello. So in doing this, you just say okay. If you click okay, we'll say calculate. You can see it's taking 1.9 to design for all. So if we click the same spacing and all checked being okay, we say okay and we click okay. You can see all footing are equal. Look at all these footing are designed by 1.9 and they are also overlapping. So in this regard, we shouldn't bother to do it multiple. It's not nice doing this way. So what you need to do is to take this off, should take this off, and we're going to design them one after the other. So it's very proper you designing one after the other. You can see that this column was designed by 1.9, but if we are designing one after the other, you can see it's not giving us 1.9, rather it's giving us 1.1, right? So in doing that with the same spacing, we are going to design one after the other such that it's going to take each column load and design for each column load the way it's supposed to be, not taking the highest load, um the highest axial load and design for a similar footing. We don't want to do that. So we have to go one after the other by clicking, and we'll do them one after the other. You can see 1.1 instead of having 1.9. You can see when your column can actually pass by 1.9 according to the load on this column that we are transferring down to the slab. So why doing it 1.5? It will be very, very much expensive. When you're considering cost at most and a larger extent, you shouldn't do that. You can see 1.5. So in doing this, we are going to trace to the column the column that we are going to, you know, get that 1.9. So you can see I've successfully, designed up to this level. We've designed all these 8 columns. I've not really gotten the one that, we have that 1.9, because like I said, it's going to take one particular one. There's a particular base that is 1.9 that it used to design. So if you see, all I'm getting here is 1.1, 1.1, 1.3, 1.300, 1 meter, 300, 1 meter, you know, 200. So I'm still trying to fetch out that particular column. This is 1, 2. This is 1, 2. So I'll keep on doing it. 1.3. Always look at this. 1.3. 1.2. Then it should be this guy. Let's try. Let's see what we've got. We'll calculate. Here we go. Here we go. You can see that it got this highest. I think we have the highest axial load at this area. So using the highest axial load to design for this footing. So this is where we have the 1.9 that the software use in generalizing all other load. You can see. So this is where we have the 1.9. So if you're going to, maybe for example, see somebody wants to run it fast, you want to just quick, it's not good. It's good for you to do it one after the other. It's not good for you to highlight all of them and just design. Otherwise, it's going to use the larger load, the larger base to design for all of them. So you can see it's only here that will have this base. Every other one we have 1 meter. So it's good for you to save the cost. Overall, this is a good design. So please, I want you to subscribe, like, share, and comment on this video. I hope we've learned today. Bye for now.